Okay, so now we're going to deal with a real sort of scenario that we have in poker and how expected value applies to it. So, we have ace-king suited, we have ace of clubs, king of clubs, and our opponent pushes all in with the queen of diamonds and the queen of clubs, and he shows us his hand because he's, not very bright. So, we now have to make a decision over whether we should call or not. So, we've got this pot here that we can win, and we also have our opponent's bet, which we can win. But if we are going to see the showdown, we have to match the opponent's bet. Okay, so first thing we want to do is we just want to look at our first option, which is to fold. And this might seem a little bit silly, but let's just think about the EV of a fold. Well, it doesn't really... If we have the best hand and we fold, we win nothing. And if we have the worst hand and, if we have the best hand and we don't call, then we win nothing. And if we have the worst hand and we fold, then we also get nothing. So the EV of a fold is 0. I just think that's worth pointing out, even though it's very obvious, but it can turn out to be useful later on comparing the EVs of different decisions. Okay, so now what is the expected value of calling? Well, let's think about it. If we call, 2 things can happen. Well, actually 3, but we're only going to deal with 2. 1, we win, or 2, we lose. We're not going to deal with a draw. So, let's try and think what the relevant things that we're going to have to deal with are. Let's go back to that sort of the last lesson we did. Well, if there's 2 possible events, our expected value equals the probability that we win times by how much we win, we'll call that W, plus the probability that we lose times by how much it costs us when we lose, so we'll call that cost C. Okay, so let's just take a step back. Well, first thing we want to do is we want to work out what the probability that we win is. Well, for this we're going to use a computer program. I think remember it was ace kings of clubs that we had. So let's put ace king of clubs in. Whoops. There we go. And our opponent had queen of clubs, queen of diamonds. Okay, so let's evaluate this. So the probability that we win is 45.9, and the probability that we lose is 54.1. So let's write that in. So, probability that we win equals 54, whoopsie daisy, 0.459, and the probability that we lose is 1 minus that, which is 0.541. Okay? Now we have to consider, well, what do we get if we win the hand? Well, our win is going to equal the pot plus the bet that our opponent makes. So if we win the hand, we get this stack here, and we get our opponent's stack as well. And our cost, okay, our cost equals, well, the bet, because we have to match the bet for the call. So let's say the cost equals the call, which also equals the bet. So now we need to think about the sizes of the pot and the bet, because I didn't specify the numbers for that. I just sort of said there is this bet and there is this pot. So let's say that the pot equals 100. Okay, and our opponent's bet equals 150. So our opponent overshoved, and shoved bigger than the pot. So now we know that our winnings going to equal the pot plus the bet, which is 100 plus 150, which equals 250. And our cost equals 150. Okay, so with that information and our EV equation that we have enough to work. We have enough to solve this problem, or at least to work out what the best decision is. So, EV equals the probability that we win, which is 0.459. So that's that bit here coming from there, times by how much we win. Well, if we have the best hand, which is 250, okay, plus the probability that we lose, which is 0.541, times by 150. That's how much it costs us. Minus 150, I should say, because we're losing here. So, yes, because the cost is negative. Maybe I should have rearranged it, but I think you get that. It's a loss here, a loss of 150 if we have the worst hand. So I'm just going to punch that into my calculator. And we'll see what it comes out as. So 0.459 times by 250 plus 0.541 times by minus 150 equals 42.6. So our expected value is a positive number. Now, just because our expected value is positive for a certain action does not mean that we should necessarily take that action, because another action may be more profitable. And our other possible action in this case, I should write down EV of a call here. So the expected value of a call is 42.6, let's say dollars. Okay. It's always worth just comparing it to the EV of our alternative, which, as we pointed out earlier, is 0. So 42.6 is a bigger number than 0, so we should call in this situation. So I expect this is the choice that maximizes, the decision that maximizes expected value is the call in this particular case. Okay.